Once they take off, of course, there will be navigational aids. Earlier, there used to be non-directional radio beacon, NDBs, as well they're called. Some places they are still in vogue. They are medium frequency navigational aids. They do get affected by weather, and that is the reason they have been, gradually being phased out. Now, the main aid, navigational aid, which is available to the aircraft is, both in military as well as in civil, is the VOR, VHF omnidirectional radio range, which guides them to a particular place or to a particular route. All these are designed based on an aerodrome's location and how that is to connect to different other aerodromes in near vicinity and of course far off as well. So navigational aids play a very important part. Another very important component is your communication. So you need to have communication between pilot and controller. So that again, we have another, the technical stream people, they provide you, the signals people, they provide you, signals branch as it is known in the Air Force, they provide you with the necessary RT equipment. Ground-based navigational aids are there, which is earlier in our time, it used to start with AD210C, then it graduated to DRDF, Digital Resolution Direction Finders, and then thereafter it became CADF, Commutated Aerial Direction Finder. Basically, when an aircraft transmits, in the tower itself, you get an indication from what direction it is communicating. So that helps you in determining where the aircraft is, so that the aircraft can be guided well, in case it requires a guidance. Otherwise, the aircraft, they have their own ADF, Automatic Direction Finder. So they home on to the NDB, concerned NDB, and they really know, as to whether they are going towards that NDB, going at an angle, or going away from that particular navigational aid. Okay, so this is as far as immediate vicinity of the aerodrome is concerned. Once they have to go from one place to another, like they are going from, say, for example, Delhi to Mumbai. Now there is an ATS route. Now this is a route, it's like a funnel, which has been designed. It's a tunnel kind of a thing, which has been designed with lateral limits and with vertical limits. So it could start, depending on the obstacles around, it could start from flight level or levels, height, 3,000, 2,000 feet above ground, right up to, generally in civil aviation, it goes up to 46,000 feet, or most of the places they are using only up to 41,000 feet. But in Air Force, our fighters can go unlimited to any extent. But those are generally the exceptions given by the, because these routes basically form part of the civil aviation airspace. Having said that, those routes are defined, and once again, the aircraft follows that route and proceeds to the destination aerodrome. There again, it will have the same setup, what was available here in the departure. By and large, there will be minor changes, and there it leaves that route, gets on to the aerodrome non-directional radio beacon or the VOR or any other aid that it will like to use, comes onto the final approach track, gets in for landing, comes, lands, and again ATC it is, which guides right from the time it comes on to the place from where it has to approach and complete the final approach to come in for a landing. After landing, again, the aircraft guides it to the concerned dispersal where the aircraft reaches and switches off. This is the whole gamut of the aircraft taking off and landing at a place. Our fighters, they proceed to local flying area, go fly there, carry out some exercise, come back and land. So this is, in very brief terms, how the aircraft are flying.
Right. So, sir, if you could also, briefly explain, we have the air traffic control towers, from where you have a bird's eye view of the entire runway and the area around that. And then you have, particularly for the landing aids, as the ground control approach, right? You have the SRE, PAR radars, which help you. And of course, today you have the instrument landing systems and very, highly technologically advanced systems for landing. If you could just take the viewers through this, so that they understand, because in civil aviation, when you're flying in the, from place A to place B, they do monitor that, call from the pilot or this thing, we are cruising at such and such level. Now we are approaching a particular airport and we are descending through this, etc., etc. We've been advised, no, there'll be a delay in landing or something like that. So I think if you could just, viewers to just understand these things a little bit in detail. ATC tower and the landing approach.
Perfect. So at an aerodrome, these services, air traffic services or air traffic control services, because for takeoff and landing, what you require is air traffic control service. Now, these services, what are they basically providing you? The first objective is to prevent collision between aircraft. There can't be two aircraft getting into collision with each other. Second is to prevent collision between aircraft and obstacles that might be there. That these obstacles obviously are temporary because permanent have already been taken into account. So the aircraft will not be flying close to those obstacles. But this temporary obstacle suddenly has come up, that there is a tent which has come up, or there is a pole which has been erected for some reason. So that comes up. So it is the responsibility of the air traffic control unit to ensure that the aircraft is separate from that obstacle while it is taxiing out on ground, very obviously, and when it is entering the runway. There could be a vehicle, there could be an animal, a dog, a blue bull, or something of that kind, coming close to that. So these are all responsibility for that. What is required? An air traffic control tower which has got 360 degrees view by and large normally, from where the air traffic controller observes the entire scenario around the aerodrome. But that obviously is limited. He can't see very high, he can't see very far, but in the immediate vicinity he is aware where the aircraft will be on ground, and that is covered. So he provides all the necessary information, which these information are also known as flight information service. So this service is also being provided by an air traffic services unit. All air traffic control units also provide this service, and they provide also the meteorological information, things like when you're coming in for landing, a thing like a wind shear, which has been reported, which creates a problem for aircraft while it is on short finals, because it gives a jolt to the aircraft. The wind pattern is such that it is not normal. Suddenly you will find that the wind is coming from west. In a particular pocket, it will suddenly start coming from east, and it will be a kind of a whirlwind thing, for an aircraft. Certainly at very lower levels, it can cause a lot of problems, and some accidents have also happened because of that. So it has become the responsibility of the ATC that once that information is received, it's their responsibility to inform to the subsequent pilots that this particular phenomena is existing. Getting back to the structure, which is required by ATC to handle all this. So you have the aerodrome control tower, from where what you provide is known as the aerodrome control service. So basically you are providing, from taxiways to runways and immediate vicinity of the aerodrome. Then the next is your approach control service, which is where, our radars have come in, ground control approach radar, which is a combination of a surveillance radar element and a precision approach radar. Surveillance radar element basically gives you a 360-degree view of any aircraft which may be flying in close vicinity of that aerodrome. Normally, the range is about 70 nautical miles, which is more than enough to cater for our aircraft which are operating in close vicinity and which are also operating in our local flying areas. And then we have the precision approach radar element, which enables an aircraft in the final approach track to follow a particular path with respect to a track, that is a heading, and also with respect to a height, that is a glide path. So track and glide path both are covered, and of course the distance information on radar is always there. When you get a hit on an aircraft by a radar, you will always come to know as to what is the bearing and distance of that aircraft. And with some radars like precision approach radar, you also get the height. In air defense radars, of course, quite a few of them have the mode C, which gives you the level. But in our ATC radars, we are generally banking on only the distance and the bearing. And of course, with the SSR, secondary surveillance radar coming in, so the whole data is encapsulated and put alongside the aircraft blip, which the aircraft appears like a blip, on the radar screen. So the complete data of the aircraft level, its heading, the direction, the distance, and what speed it is operating, all those data are there. But at this point of time, it will suffice to tell you that approach control, again, is a very, very critical and crucial part of the air traffic controlling, because here is where the aircraft immediately after getting airborne requires any assistance. It is the approach control unit with the radars. It helps. Similarly, while it is coming back for landing, these aids enable the approach control unit to recover the aircraft safely. In the same thing, I would like to also tell you that the pilot have their own pilot interpreted aids, like instrument landing system. It is something very, very similar to the precision approach radar. And both are actually categorized as precision approach category 1 equipment internationally, wherein it allows you to get down to decision height of 60 meters, 200 feet. So you can come right up to 200 feet. From there, you have to generally look around. If you see things, to continue approach and land, you continue approach, otherwise you execute a missed approach.